We're going to look at finding the area between two curves. I want to start with a graph and some integrals, but before we do that, if this is the first time you're seeing my face, hi, my name's Dr. Marissa May. I'm on a mission to help students feel confident in their math classroom. And so this video is just one of the resources that I provide, and I have a lot of others. So if you need something else, you need help, you want to see a video of another type, you need a resource to help you with a particular concept, let me know in the comments below. I'd be happy to help in any way that I can. Also, don't forget to hit that like and subscribe button. That way you get a notification every time a new video is posted. Well, let's jump right in. We're going to kind of build the concept here, but I want to begin by graphing this function. You can take the time and plot some values. I'm actually going to hop over onto the Desmos graphing calculator. I'm going to put this equation in there. -1/2 x squared minus 2x plus 4. And the reason I do this is because Desmos highlights some key points for me. It looks like I have a point at 0, 4. Looks like my maximum is at -2, 6. So I can get some other points. Makes it kind of nice. And so I'm just getting the points from the calculator there. By the way, I will link Desmos below so that if you need to use it, you definitely can. Okay, so coming back now, so we graphed it. It says to find the value of this integral. So we're going to do the integral from -5 to 0 of -1/2 x squared minus 2x plus 4. And we're going to take the antiderivative. So we're going to increase that power by 1, making that x to the third. And then we're going to have -1/6 because the -1/2, and then we divide by a 3 will give us -1/6. Then I've got minus x squared, then plus 4x, and we're going from -5 to 0. So we're going to plug in 0 first. Very easily going to get all 0 there. Minus, and then I'm using a parentheses to put in the -5. So -5 to the third gives me -125 times the -1 is going to give me 125 over 6. All right, then minus -5 squared is going to be a positive 25. And then 4 times -5 gives me -20. So I'll go ahead and distribute this negative. That's going to give me a -125 over 6 plus 25 plus 20. So it looks like I've got 45 and I've got -20 and 5/6. Does that sound right? -20 and 5/6. So I've got 23 and 1/6. Or you could go back to 139 over 6. Okay, now using one color, shade the region for which this represents. I'm going to use a highlighter here. So that's going to be from -5 to 0. So that's going to be this region in here. So notice it's positive. That makes sense because the majority of this area, or all of this area, is above the x-axis. So yes, we are going to get a positive value. Now, the next one says to graph this line, 1/2 x squared, I'm sorry, 1/2 x plus 4. Now, that one I'm not going to need a calculator for. I'm just going to graph it at 4, and then I've got a slope of 1/2, and I'm going to use a straight edge here. Well, I didn't get a very good graph there. Let's see if I can use a different colored pen, might help. Good. All right, there we go. And then find the value for that integral from -5 to 0. So we're going -5 to 0, this time of 1/2 x plus 4. So antiderivative there would be 1/4 x to squared plus 4x. and we're going from -5 to 0. So I'm going to plug in 0, and then I'm going to put in -5. So that would give me 25 over 4, and then minus 20. So again, we're going to distribute that negative. That gives me a -25 fourths plus 20, or -6 1/4 plus 20, which will give me 13.75. And then I want to use a different color this time to highlight what that integral represents. So that is this region here, the pink one, just the pink one. So the question is, what do you suppose you would do to find the area of the region located between the two curves? And very simply, we are going to subtract those. So I need to get a better pen there. We'll go from -5 to 0, and we'll do f of x minus g of x dx. And very simply, that's going to be when we subtract these two. So I had 139 over 6 minus 13.75, and we can subtract those two. And I end up with 9.417. Okay, so very simply, if you want the area between two curves, you simply do the integrals of the curves subtracted. Make sure you have the upper curve first, then subtract the lower curve. Okay, now let's do them together, right? We'll do the integral from -5 to 0 of f of x, which is our 1/2 x squared minus 2x plus 4, minus my g of x, which is 1/2 x plus 4 dx, right? Let's clean up our integral just a little bit. I've got -1/2 x squared. I'm going to have minus 2x minus 1/2 x. That gives me minus 5/2 x. Then I've got plus 4 minus 4. So that one goes away. Let's do the antiderivative now. The antiderivative of -1/2 x squared would be -6x cubed. And the antiderivative of 5/2 x would be 5/4 x squared. And we're going from -5 to 0. So again, we plug in our bound of 0 first, and then we plug in our bound of -5. So -5 cubed gives me -125 times times -1 gives me positive 125 over 6. And then I put in -5 squared would be 25 times 5 would be 125. And then distribute your negative. And you will find that we get the exact same values that we had before. I still get 9.417. So notice whether I do the integral separately or I do them together, I get the same value. Okay. So we will find that we can separate them if we want. We can do them together in an integral. The choice is yours. So let's look at the problem here. Find the area of the shaded region R, which is bounded by y equals sine of pi x. Notice that is this curve. And y equals x cubed minus 4x. So important that we see that these two curves, this region here starts at 0 and it ends at 2. Also, notice the sine curve is the top curve the entire time. If that changes, we have to do something a little different. So we'll set up our integral from 0 to 2. Top curve is that sine of pi x minus the bottom curve, which is x cubed minus 4x dx. Go ahead and distribute your minus. So you have minus x cubed plus 4x. And now we take the antiderivative. Now I want you to be thinking u substitution here. So you've actually got let u be pi x. So, oops, pi x. So du is pi dx. So you've got a 1 over pi coming in front. And we've got the integral of 0 to 2 of cosine of u du. And I know those are x's bounds. I'm going to come back to them here in just a second. Now I'm going to go ahead and do the antiderivative for this part because I can. And then I'll get my antiderivative here. That would be sine of pi x. I'm going to go back to x here just to make it a little simpler for us all. And then I'm going from 0 to 2. Okay, so plug in your 2 first. Sine of 2 pi is 0. That's nice. Minus 2 to the 4th is 16 times 1/4 is 4. Plus 2 squared is 4 times 2 is 8. And then I'm going to plug in 0. Sine of 0 is also 0, and I get zeros here. So I get -4 plus 8. I get an area of 4 there for the region R. Okay. Notice sometimes it's easier to separate the integrals. Sometimes it's easier to do them all together. The choice is really up to you. Now, the next few questions are going to be good examples of what you might see on an AP type exam, but you could definitely see the parts A, B, and C as we go through here. So I hope that helps. So pictured to the right is the graph of this curve f of x and a line L, which is tangent to the graph at the point 0, 3. So we want to find the region of R. So notice that in order to do the region of R, we need the bounds. So we need to know when this graph R hits the x-axis. So I'm going to go back to Desmos. Let me switch our view here. And I'm going to put the graph, I'm sorry, the equation in for Desmos so we can take a look. All right. So there we are. Let's see if I've got that typed in right. Yep, we've got it. Should have a minus here. My graph wasn't looking like the one on the paper, so I wanted, there we go. Okay, so what we need is we need this value. That's our bound for R. So we're going from -1.373 to 0 of my curve x cubed over 4 minus x squared over 3 minus x over 2 plus 3 cosine x dx. Now, the beauty of using the calculator, and I'm going to use Desmos, but you definitely could use um, the 83 or the 84 if you want. I'm just going to label that f of x, and then I'm coming here to do integral. Notice I typed int, the integral symbol shows up. I'm going to put my bounds in here, and then I'm going to put f of x dx. And I get my answer here. Now, if you are going to take the AP exam, something to know that AP is going to want this integral written out, and then you can solve with your calculator, okay? Don't feel like you have to do the antiderivative if you are given your calculator. Now, let's then look at part B here. Find the equation of L that is tangent to the graph at 0, 3. So in order to do a tangent line, this is a throwback to earlier in your calculus course, and that is you want to take the derivative. So we'll take the derivative here of f of x. That would be 3/4 x squared minus 2/3 x minus 1/2 minus 3 sine of x. And now you want to plug in your point. So you want to plug in 0 so you can get your slope. So it's going to be 0 minus 1/2 minus 3 sine of 0. And sine of 0 is 0. So your slope here is negative 1/2. Now you can write your equation for your tangent line using your slope and your point. So y minus 3 equals negative 1/2 x minus 0. All right. Now, part C then asks us, at what ordered pair other than 0, 3 does the line intersect the graph? So meaning we're asking for what is this point? Where does this line intersect that graph? Okay. So what I'm going to do is go ahead and solve my equation of my line. And then I'm going to set these two equations equal to each other. And I'm going to go back to Desmos. That's the best place to do this. So when I go back to Desmos, let me show you. I'm going to take out this integral because I'm done with it, but I'm going to keep f of x because all I need to do is tell it that I want to see where negative 1/2 x plus 3 equals f of x. Okay. And I can see it's at this point, which by the way, that's the point we already know, 0, 3. And then I'm looking for this point. Oops. Let's see if I can get Desmos to tell me what that point is. Well, let's do this. Let's just take that equal to f of x part off. There we go. And then Desmos will highlight that point for us. There we are. There we go. And so we find it at positive 3.39 and 1.305. Now you may be thinking, well, why did it want to know that? Well, it's kind of setting you up to find the area of region S. Okay. So region S, notice, goes from 0 to that intersection point. So we're going to find the integral from 0 to this x value, 3.39. And we're going to do the line, negative 1/2 x plus 3 minus f of x. And again, we're not going to integrate this by hand. You're definitely going to put it in your calculator. So let's see how we do that. We'll do the integral from 0 to 3.39. Then we'll do negative 1/2 x plus 3 minus f of x dx. And we get 6.982. Okay, now notice we did it between the two curves. That's important. And I also want you to see that many times in AP questions, you're asked to find one region. It may not be a region that's between two curves. It may just be an area like this. You're asked to do something else, go back in the course, and then you're asked to find an area between two curves. So meaning when you see a free response question, just because there's one part that's area doesn't mean that the entire question is going to be about area. Keep that in mind. Let's look at one more here. So picture to the right are regions R and S that are formed by these two curves. Okay. It's important. You might want to plug them in your calculator to see which one is which. But I have found that this curve is the f of x curve. And this curve is the g of x curve. Okay, so first thing is find the points of intersection. So this is where we're going to look on the graph and find where f of x equals g of x. So again, going back to Desmos, and let me take these curves out. So I'm going to label f of x just like it does in the problem. That'll make it a little easier. There we go. And then I'll do g of x is equal to 4 to the negative x. Okay. And we're only looking for these first two intersections. So there's the first one at 0.178, 0.781. And then the other one will be the second one we see them intersecting, which is right there. And that's 1.25. So now we're looking for the area of region R. So notice in this region, we're going from 0 to that first intersection point. So we're going from 0 to 0.178. But I want you to notice that g of x is on top here and f of x is on the bottom. So we're actually doing g of x minus f of x dx. And again, I'm going to let Desmos do that. So I'm going to do the integral from 0 to 0.178. And remember also it's g of x minus f of x dx. And we get 0.065. Then we want the region of S. And so that's from the first intersection point to the second one. So this time we're going from 0.178 to the second intersection point, which is 1. And this time we're doing f of x minus g of x because f of x is the curve that's on top of the region S. So again in Desmos, we'll just do the integral from 0.178 to 1, and that's of f of x minus g of x. And for this one, I get 0.410. And then finally, we asked to find the area of the unshaded region. So we want to find this down here. Okay, so this is a little tricky because we have to look at, we actually change curves. So I'm going to do it in two pieces. I'm going to go from here to here, and I'm going to use it of f of x, since that's on top of this region. Then I'm going to go from here to here, and I'll do g of x. So two separate integrals needed on this one. The first one, I'm going from 0 to the first intersection point, which is 0.178, and I'm doing it for f of x, because that's the region, I'm sorry, that's the top curve for this unshaded region. Then I'm going to do the integral from the first intersection point to the second. And I'm going to do this one of g of x, since that is the curve that's bounding this region. And I'm going to have to do them separately here because the bounds are different. So let's see what Desmos does. I'm going to do integral from 0 to 0.178 of f of x dx. And I'm going to add the integral from 0.178 to 1 of g of x dx. And there's where I get both of them. Now, if you're using the 83 or the 84, it still will do all of these. It just doesn't give you that nice visual that Desmos does, but it still will make all of these calculations for you. So I hope that helps you with the area between two curves. I know this is a big topic for any calculus class, and it's almost guaranteed to be one of the free response questions on the AP exam. So it's one you definitely want to spend some time and effort with. If you need help with that, please feel free to let me know. I would be glad to share some other resources that I have on this topic. And I hope to see you soon again. Bye for now.